Here are the solutions to the Unit 2 review. Now it's important to understand exactly what's being asked because a lot of the processes for these problems are going to be the same, but they can have very different answers. So for this question, we're given a polynomial function g of x. We're also given that -3 is a 0, so that's sort of our starting point. And then we need to express g of x as a product of linear factors. So that means we want to factor this polynomial completely, and synthetic division is what's going to help us. So first we start using synthetic division. We put the -3 on the shelf, then we're going to have 1, 7, 9, -9, because we have all of our powers of x in descending order. We'll start by bringing down the 1. This will give us a -3. 7 minus 3 is 4. This will now give us -3 times 4. It's a -12. 9 minus 12 is a -3. -3 times -3 is a 9. And we should expect to get this remainder of 0. So now we can say that g of x factors into an x plus 3 if -3 is a 0. And then this is the remaining polynomial, which will become an x squared plus 4x minus 3. Well, we need to try to factor this, but it's not going to factor just into 2 sets of parentheses. So we need to find the individual zeros here. So now what we need to do is set this equal to 0. We can use a quadratic formula. So we're going to say x is going to equal the opposite of b, so -4, plus or minus square root of b squared, so we'll get 16, minus 4 times a, which is 1, times c, which is a -3, all over 2 times a, which is just 2. So now we get -4 plus or minus square root of 16. This will give us a positive 12 when we multiply -4 by 1 by -3, all over 2. Simplifying this, we'll get -4 plus or minus square root of 28, all over 2. We can simplify radical 28. That would become a 4 times a 7, so it becomes 2 radical 7 over 2. So then we get, dividing both of these by 2, we'll get a -2 plus or minus radical 7. So those are the other two zeros. So how are we going to write those in? We'll go back up here. We'll still have x plus 3. Then we'll do an x minus a -2 plus radical 7. And then we do an x minus a -2 minus radical 7. So simplifying this, we get the x plus 3. This will become x plus 2 minus radical 7, and then an x plus 2 plus radical 7 when we distribute the negative there. So this is our answer, because now this is written as a product of linear factors. Okay, number 2 was very similar to the first question off of the activity 4. We want to find the x-intercepts and the coordinates of the vertex for this parabola, y equals x squared minus 2x minus 24. So let's first find, we can do the x-intercepts. We're just going to set this equal to 0. As you guys saw in activity 4, there were a couple ways you could do this. We could just use the quadratic formula, or once you get this in vertex form, you could set it equal to 0 and solve that way. Or we could see if it solves by factoring, which it actually will. So we could do an x minus a 6 and an x plus 4. So it was a little bit easier than having to use the quadratic formula, but it still would have worked out that way. So here x would equal 6, x would equal -4. So our x-intercepts, we'll write these as an ordered pair, 6, 0, -4, 0. And make sure you guys clearly identify your answers. So now let's get the coordinates of the vertex. So remember, the vertex is hk, so we could use our little formula here. H is equal to the opposite of b over 2a. So the opposite of b becomes a positive 2. 2 times a is this 1 right here. So h is 1. K is now going to equal, if we call this f of x, it'd be f of 1. So we just substitute the 1 in here. So we'll have a 1 squared minus 2 times 1 minus 24. So this gives us a 1 minus 2 minus 24. And we get a -25. So our vertex is 1, negative 25. So now the vertex form So right here, this 1, that's a. So a is equal to 1. We're going to substitute this in the y equals a times the quantity x minus h squared plus k. So y is going to equal a is 1, so I really don't have to write this here. X minus h, so we're going to get an x minus 1, that quantity squared, plus our k, so plus a negative 25, or just minus 25. So here's vertex form, here's our vertex down here, and here's our x-intercepts. All right, in this question, we're asked to graph y equals x squared. Then we want to use translations to graph this. So they're both parabolas, they're both quadratic, and you want to plot 5 points for each graph. And again, I'm going to show you how to do this by counting, and then we can also do this by making some tables. So when I just go to graph the parent graph, y equals x squared, my vertex is at 0, 0. And again, this is how you count just for a basic parabola. If you count 1 over to the right, you count up that many units squared. So over 1 up 1 squared is just 1 on both sides. If I count over from the vertex 2, we're going to count up 2 squared, so 4. Or again, you can make a table. So for y equals x squared, my vertex I'll put right here in the middle, 0, 0, of negative 1, negative 2, 1, and 2. So if y is equal to x squared, this will give me a 4, negative 2 squared, negative 1 squared is 1. 1 squared is 1, 2 squared is 4. So I just want to go ahead, and those are my 5 points I want to plot. So this is y equals x squared. So now for y equals x minus 2 squared minus 5. Now that we've worked enough with quadratics, parabolas here, I know my vertex would be a 2, negative 5. So I'll plot that. Both of these are going to open up. And again, from here, I can count the same way, or we can make our table. I put 2, negative 5 in the middle. I'm going to go 2 to the left of the vertex, so 1 and 0. Then we'll do 3 and 4. And I could substitute this right into here. So here I'm going to have 0 minus 2 squared, so that's going to give me a 4. 4 minus 5 is negative 1. So I'll plot this here. 1 minus 2 is negative 1. Negative 1 squared is 1. 1 minus 5 is a negative 4. If you look here from the vertex, like I counted over 1, up 1. And then to get to this point, I counted over 2, up 4. Now this should be symmetric, so I should get another negative 4 here, because 3 minus 2 is 1. 1 squared is 1. 1 minus 5 is negative 4. And then I should get a 4, negative 1, because 4 minus 2 is 2. 2 squared is 4. 4 minus 5 is negative 1. So this is y equals the quantity x minus 2 squared minus 5. Now, using translations, all we're really saying is that the second graph shifted 2 units to the right and 5 units down, but everything else, all the points stayed in the same location with respect to each other. All right, for number 4, we have a piecewise function, so we want to graph this function. So it's very important, especially for a problem like this, that we label or number along our x-axis. So notice all of these are the 4s. So I want to go to 4, negative 4, counting by 1s here, so that'll be a 10. Go to negative 10 down here. All right, so my first function, that is a parabola. So let's talk about this over here. Now this is only going to show up in between the 4s. It's going to be included over here because of the or equal to, but not over here. So if I wanted to get this really in vertex form, I could start right here. Technically, I don't have anything in the parentheses, so my vertex is just going to be 0, 10. So I'm going to start up here. And again, you can make a table of values. My parabola is going to open down. So in this case, I'm going to count over 1, down 1 on both sides because my a value is just a negative 1. Count over 2, down 4. or like I said, you can make a table of values. But I need to go a little bit further because I need to go from -4 to 4. So if I count over 3, I need to count down 9. So that would get me here. I'm still not to the 4s. So if I counted over 4, I have to count down 16. So this is counting down 10 and then 6 more. So this is where I'm going to put an open endpoint. And then over here, I'll put a closed endpoint. So this is where my parabola is just going to show up. So luckily, I don't have to erase anything beyond this. I know that's all I'm going to graph here. So we'll try to draw this in as best we can. We'll go to there. I'll go to there. So our parabola shows up between -4 and 4, including the -4 here. Next, I need to graph a line. So this is, I'm going to rewrite it this way, y equals -x minus 5. So this is just a line. Our y-intercept is -5, and our slope is -1, or -1/1. So because this only shows up for all x values greater than or equal to 4, I'm going to kind of put some ghost points and then I'll go back and I'll erase. So technically, I'm going to start here at -5. But I'm going to erase that. And I need to count down 1 over 1. Down 1 over 1. So I'm still not going to include those points. I'm going to erase them. This is just a way to get started. Down 1 over 1. Still can't include that point, but right here I definitely can. And then it's just going to go like this. So I need to go back and erase these points. But this is the line y equals -x minus 5. And because the graph is not connected, this is not continuous. All right, for number 5, unfortunately on the handout, I couldn't get the color to come out here, but now you could clearly see the graph of H is in red, graph of F is in blue. So the graph of F in blue is translated a whole number of units horizontally and vertically to obtain the graph of H, which is in red. The function f is defined by f of x, which is equal to absolute value of x. Write down the expression for h of x. So they're still both absolute value functions. So we're going to say h is translated. Notice you're going to count 1, 2, 3, 4 units to the right, and then 2 units down. So what is that going to look like? So we're going to say h of x is going to be the absolute value. 4 units to the right will become an x minus 4, and then 2 units down would be a minus 2. That's it. For number 6, given the graph below, state the equations of the horizontal and vertical asymptotes, the x and y intercepts, and the domain and range. So again, clearly identify your answers. So we're going to say, here's our horizontal asymptote labeled, and this is right here. This is our horizontal asymptote. That is always an equation of a line. Horizontal means y is going to equal, and we're going to have a -1. Vertical asymptote is right here. That's always going to start with x equals, and then this will become an x equals 2. X-intercept is where the graph crosses the x-axis. So it looks like it crosses right here. So that's at -6, 0. The y-intercept, where our graph crosses the y-axis, this doesn't happen down here, but it crosses right here at 3. So we'll say 0, 3. The domain is all the x values, so if we have to skip over any, we exclude it. So if we're coming from left to right, we have to jump over x equals 2. So our domain is going to be -infinity to 2, union with 2 to infinity. And the range, how far down to how far up, so we just have to jump over the -1. So this is -infinity to -1, union with -1 to infinity. 7, identify the relative extrema, so all the maxes, all the mins, the local maxes and mins, and where they occur. So we're just going to write these out in statements here. So right here and here we have our local max or a relative max, so we would say we need two statements here. That the relative max, I'm going to first go with the furthest left one, is y equals -1 when x equals -4. Our second one, y equals 3 when x equals 0. Our relative mins are right here and here, so we have to write out two statements here. Oops, we want a min. Relative min, first go with the furthest left one, is y equals -3 when x equals -2. The other one, relative min, is y equals 0, or right on the x-axis here, when x equals 3. So that's exactly how you want to write these out. All right, number 8, we practice a question like this in class on Wednesday. We want to find the equation of the quadratic function f that has a vertex at 4, 3 and passes through the point 5, 5. So again, vertex form is going to help us here. This is how we want to end up writing our equation. So that, again, it's y equals a times the quantity x minus h squared plus k. Our vertex is 4, 3, so this is h. This is k, so we're going to get y equals a, then it will be x minus 4 squared plus 3. Now we have to find a, so now we're going to use the 0.55 for x and y. So we're going to get 5 equals a times the quantity, x is also 5, minus 4 squared plus 3. So we get 5 equals a, this will be a 1 squared plus 3. 1 squared is 1, so we just get a plus 3. So a is going to equal 2. So our final answer now, y is going to equal a, which is 2, times the quantity x minus 4 squared plus 3. For number 9, consider the following quadratic equation. We want to write g of x in vertex form, and that's just a dash there. We're going to identify the vertex, and then we're going to graph this. So there's a couple ways we could do this. We can just go ahead and find h and k, or we can complete the square here. And I'm actually going to show you completing the square. So we want g of x to equal, and I'm going to start by factoring out a 2 from the first two terms. I'm going to leave a little bit of space. And then I want to add half of 6 is 3, 3 squared is 9. So I'm actually adding an 18, so I want to subtract an 18. So now we're going to have 2 times the quantity, and if I factor into this perfect square trinomial, it's going to factor into the quantity x plus 3 squared. Then we're going to get a plus 1. Now you could do this by finding h as well. So h will be the opposite of b, so that's going to be a -12, over 2 times a, so 2 times 2 is 4, so that's going to give us a -3. And then k is going to become 2 times -3 squared, I'm just following this, plus 12 times -3 plus 19. So this will give us 9 times 2 is 18 minus 36 plus 19. 18 minus 36 is a -18 plus 19, so k is 1. So no matter how I look at this, my vertex here is going to be a -3, 1, and that's what I got here, -3, 1. So this answers part A. Say g of x is going to equal this. This is vertex form. This is part B. And then we want to graph this. So I'm going to start at my vertex. Again, I'm counting by ones on my coordinate plane here. So -3, 1 is right here. This parabola is going to open up. Now, since a is 2, I'm going to show you how you can just do this by counting, but we'll also make a table. If I count over 1, 1 squared is 1, but now I need to double it. I need to go up twice as many. If I count over 2 from my vertex, 2 squared is 4. I double that, so now I need to go up 8. So here are my 5 points. But we can also make a table. So my vertex is -3, 1. I want to go a couple points to the left and then a couple to the right. And I'm going to put this in here like this. 2 times the quantity x plus 3 squared plus 1. So if I'm at -5, -5 plus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. So I have the point -5, 9, which shows up on my parabola. That's right here, -5, 9. -1 would also turn out to be 9 because there's symmetry. So here's my -1, 9. If I substitute in a -4, -4 plus 3 is -1, -1 squared is 1. 1 times 2 is 2, 2 plus 1 is 3. So these should both give me 3. So I have the point -4, 3, which is right here, and -2, 3. So here's part C. All right, I'm just doing 10 problems per video, so this will be the last one for this video. Here we're just going to do some reflections. So what could be helpful is if we make a table for y equals f of x, or we could say we're just going to reflect when the negative is on the inside, reflect over the y-axis. So we could just put our points here, here, and here, and if it helps, we're going to reflect over the y-axis. So here I'm at the ordered pair -7, 2. So I'm just going to flip that around to get 7, 2. This point would just stay right here. And then this point down here, -2, 2 will just become, I'm sorry, -2, -3 will become 2, -3. So this is our graph reflected over the y-axis. Like I said, you can make a table or you could just see that symmetry that's right there. Now for this one, when the negative is out in front, this is going to be a reflection over the x-axis. And again, with where this negative shows up, so this is saying we're taking the opposite of the y's. Over here, with it being on the inside, we were taking the opposite of x's. So if we had a -7, we make it a +7. And that's what gives us, or how we're supposed to know which axis it's going to reflect over. So again, I'm just going to take some points here. Maybe those 3 right there. And I want to reflect over the x-axis. So this point right here at 6, -2 will now become 6, 2. This one's going to stay the same. And this is at 2, 6, so then we want 2, -6. And we'll just draw our point.